Hi, welcome back. Today we're going to be studying inverses. Remember I spoke earlier in the school year about how there would be some repeated lessons, and this is the second repeated lessons on inverses. We're just changing the parent functions which are involved, and again I'm going to use Desmos to help fill in the graphs, so please fill in from Desmos what you see on your notes packet here, even though I will not be filling in the graphs on here. All right, we'll begin by looking at the graph of the function and its inverse. Notice that the original function is a parabola. Therefore, the inverse of that function must also be a parabola. That's going to play a very important role later on, and I'll explain that in a little bit more detail once we get into the problems. Okay, so from looking at your picture, which you have copied down, the vertex of the original was 0, 3, and the vertex of the inverse was 3, 0. The domain of the original was all real numbers, and the inverse was, the domain of the inverse was 3 to infinity. Now, because domain and range are switched on both the original function and its inverse, the range of the original is 3 to infinity, and the range of the inverse is all real numbers. So all of these values here represent the inverse function. All of these values here represent the original function. Now what we're going to do is we're going to explore this algebraically so that you guys can see algebraically how inverses work. Incidentally, the line of symmetry is always the line y equals x. Please keep that in mind as you're doing these problems so that you know and recall that readily. So we begin with f of x equals x squared plus 3. The next step I'm going to do is I'm going to switch my x's and y, so I get x equals y squared plus 3. Subtracting 3 to both sides gives me x minus 3 equals y squared. To get rid of the square, I must square root both sides. So it's going to be y equals the square root of x minus 3. Now let's go back and take a look at our graph for just a second. I'm going to open this up, and I'm going to shut that one down for a second. So notice the inverse, as I have it drawn as y equals the square root of x minus 3, is not truly the inverse of the original function. It's missing a branch. Thus, the need for the value plus and minus so that you see both arms or both branches of the parabola. So that means that the step that I missed here was to include the plus or minus. So please remember, whenever you square root both sides of an equation, to always include the plus or minus of the form. The last step is to change it back into function notation. F negative 1 of x equals plus or minus the square root of x minus 3. All right, question number 2. The tables have been filled for you, so go ahead and fill those in. Let's move on to Desmos so you can see what it looks like in its inverse form. And there it is right there. You can see how the line of symmetry goes right between and intersects at the two places where the graph itself intersects as well. Very useful to help you see that. All right, the vertex of the original is 0, 3. The vertex of the inverse is 3, 0. I hope you recall that pattern that you see here. We're simply switching the x and y values regardless. The domain of the original is all real numbers. The domain of the inverse is 0 to infinity. The range of the original is 0 to infinity. And the range of the inverse is all real numbers. Again, This is your inverse function, and this is your original function. So you're not confused later when you look back on it. All right, so we're going to start with f of x equals x minus 3 squared. I'm going to switch x and y here, and I get x equals y minus 3 squared. Square rooting both sides, and I'm going to get plus or minus the square root of x equals y minus 3. Add 3 to both sides. Remember, that goes on the outside. So now I get y equals plus or minus the square root of x plus 3. The last step is to put it back in function notation. So f negative 1 of x equals plus or minus the square root of x plus 3. And that's your final step for that particular problem. All right, question number 3, again, has been given to you, but now we're in square root form. All right, we'll begin by looking at the graph once again. And you can see here that it still follows that same model that we did before on the previous one, where both intersection points also intersect with the line of symmetry y equals x. All right, the vertex of the original, -3, -1. The vertex of the inverse is -1, -3. The domain of the original, -3 to infinity, and the domain of the inverse is all real numbers. The range of the original, all real numbers, and the range of the inverse is -3 to infinity. So you can see your pattern there, switching back and forth. All right, the last thing we'll do is algebraically show how we got from one to the other. Now we're going to begin with x equals plus or minus square root of y plus 3 minus 1. Adding 1 to both sides gives me x plus 1 equals plus or minus square root of y plus 3. Squaring both sides of the equation gives me x plus 1 quantity squared equals y plus 3. Subtracting 3 to both sides will give me y equals x plus 1 quantity squared minus 3. Now, because there is no restriction on the original, that's the plus or minus part, there will be no restriction on its inverse. Now, that's not going to be the case for these next two problems, so pay attention very closely. All right, question number 4. It says, find the inverse and state the domain of the inverse. Well, if the domain of the inverse is restricted because the inverse is a parabola and the original is a square root, we're going to have to figure out what that is by looking at it algebraically. So I'm going to go ahead and start with x equals the square root of 4 minus y minus 1. Add 1 to both sides, and I get x plus 1 equals square root of 4 minus y. Square both sides. X plus 1 quantity squared equals 4 minus y. Subtract 4 to both sides, and I get negative y, please don't forget that negative, x plus 1 quantity squared minus 4. Multiply or divide both sides by -1. Remember, it has to go to everything. You could get careless here and leave out that, but please don't. And I get y equals negative x plus 1 quantity squared plus 4. Writing it in function notation, I get f negative 1 of x equals negative x plus 1 quantity squared plus 4. Now let's take a quick look at the differences between the algebra here in question number 3 and the algebra here in question number 4. To figure out why there's a restriction there, we have to look carefully. Notice here the plus and minus has been used, but notice here no plus or minus has been used. There is no restriction to this because the inverse is a parabola and the plus and minus makes the original a parabola too. There is no restriction here, so that means, or there is a restriction here, which means we have to restrict the parabola as well. Okay? A quick graph of both of these will show you what you're looking at so that you're careful to pick the right side. So what I'm looking at is I'm looking at the domain of the function. Well, if the domain of the inverse was the range of the original, it's easy for me to figure out what the range was by remembering that there's a definite starting point at -1. Let me think back on that again. Remember, -1 is k. Remember, h and k? K is the definite starting point of this graph. Well, that's the range because it's k. The domain of the inverse is the range of the original. I was hoping you would pick that up from our previous 3 questions. The domain of the inverse is the range of the original. Now, the reflection does not occur vertically. It actually occurs horizontally. It's a pretty complicated problem, but that's okay. We'll figure it out. So that means that my domain of my inverse is the range of the original, which was 1 to infinity. So it takes a lot of thinking there to remember, but if you set it up properly and remember what h and k actually are in a square root function, you'll be just fine when you solve that problem. All right? The last one we're going to do together, I'm going to let you do number 5. So number 6. Number 6 will be a you do. I want to do number 5 with you together. So it's going to be x equals -2 y minus 3 squared plus 1. I'm going to use PEMDAS. That's what I've been using the whole time. And I get x minus 1 equals -2 y minus 3 squared. Now don't get too quick on this exponent. We still have this number here, so we got to divide it out to the other side. And that's going to give me x minus 1 divided by -2 equals y minus 3 quantity squared. Square rooting both sides here, and I get plus or minus x minus 1 divided by -2, all square rooted, equals y minus 3. I'm going to add that to the other side of the equation. So that's going to give me plus 3. Y equals plus or minus the square root of x minus 1 divided by -2 plus 3. The next thing I'm going to do is kind of clean this up. That's pretty messy inside there. So I'm going to factor out that -1/2. See how it's on the bottom? It's a 1/2. So that's going to give me f to the -1 of x equals plus or minus the square root of -1/2 times x minus 1. Remember, I factored out that -1/2, which is why it's there, plus 3. Okay, now at first glance this does not look like it has a restriction, but in fact it does. Notice that I have a domain which is only positive. So back to Desmos, here we go. Okay, and let's take a look at question number 5 real fast. Notice that this is the original, the blue line. Let me pull that out so you can see it, with the restriction of x is greater than 3. Notice it's not a full parabola due to the restriction. Therefore, if I put the plus and minus on this particular problem, I will not get the inverse that I'm looking for. So in this particular case, you now notice that you don't need the plus or minus, you only need the positive side. This is a lot to remember and a lot to take in, so you want to think carefully about it, about when to use the plus and minus and when not to. A lot of different scenarios here, and we've gone through a lot of different ways where some have restrictions and some don't. I compared these two earlier. You can see why we had a restriction, no restriction here, but we had a restriction here in our inverses. Very important to see that. If there's a restriction in the original, there will be a restriction in the inverse. If there's no restriction in the original, there will be no restriction in the inverse. Now, I'm sure there'll be some questions on this, so please go ahead and write some things down that you've got bouncing around in your head right now so that we can have some good conversations tomorrow.